This is Lab 3, Circuits for Physics 2212. So for the purpose of this lab, I applied the principles of energy conservation and current conservation. We predicted the behavior of circuits containing resistors in series and parallel. We used multimeters to measure the actual values of the conventional current and potential differences in the circuits, and then we examined the behavior of the ohmic resistors and capacitors. So a quick preview into the results. First, I calculated the current to equal 0.204 amps, the total voltage to be 3 volts, and the time constant to be 6.28 seconds. Then the system of this lab are the circuits, and the surroundings are everything else. So these are the main physics principles I used in the lab. I used Ohm's law, capacitance, node rule, loop rule, conservation of energy and charge, resistors and capacitors in series and parallel, and time dependence in RC circuits. So the first experiment in the lab was for charge and energy conservation. For this part, I simulated the circuit given two 1.5 volt batteries, 2 ohm resistors, one 47 ohm and one 100 ohms, and then 2 ammeters. Some assumptions I had for this lab is that the currents will be the same with a value of 0.2 amps. The total voltage, again, is 3 volts. And then, as you can see, the experimental results I got are the actual current to be 0.02 amps and the verse to be negative 0.02 amps. So the results match my assumptions as above. So next, we replaced one of the ammeters with a voltmeter. And from this caused the total voltage to be, it showed that the voltage was 3 volts and it changed the currents to be 0 amps. So then we removed the voltmeter from the circuit and replaced it with a wire close to the circuit, then used the voltmeter to measure the potential difference for each part of the path around the circuit. These are the potential difference values I got from each part of the path. After adding all the parts, which was 3 plus negative 0.96 plus negative 2.04, I got the round trip to equal 0. And the ammeter readings don't change because there's no current going through it since there's a high resistance in the voltmeter. So lastly, we replaced the voltmeter with an ammeter in parallel with the 100 ohm resistor. This has caused the resistance to decrease and the current to increase from 0.2 amps to 0.6 amps. Then I calculated the resistance. I did the voltage divided by current, so I got 48 ohms for the 47 ohm resistor, 102 ohms for the 100 ohm resistor, and 0 ohms for the wire and the ammeter. So the second experiment of the lab deals with RC circuits. For this part, I simulated the circuit with a 10 ohm bulb and a 20 ohm bulb using a 9 volt battery and 200 millifarad capacitor. First, I connected the battery to the 10 ohm bulb and the capacitor. And after this, I saw that the bulb lit up very quickly and then it slowly started to go out. Then I disconnected the battery and connected it directly to the bulb. Again, from this, the bulb lit up quickly and then slowly started to go out. After doing this with the 10 ohm bulb, I repeated it all with the 20 ohm bulb. And from that, for the 10 ohm bulb, it took 10.4 seconds to charge and 13.3 seconds to discharge. And then for the 20 ohm bulb, I got 18.4 seconds to charge and 24.1 to charge. Lastly, I created a graph for the time-dependent voltage across the capacitor. The predicted time I got was 6 seconds for multiplying the resistance times capacitance. From the graph, you can see the slope is negative 1.92, and so the RC is negative 1 divided by the slope, which resulted in 6.28 seconds. These are the main results from each part. For change in energy conservation, we got the current to be 0.2 amps, the voltmeter got 3 volts, and a current of 0, and then the round trip was 0 volts, and then for the ammeter in parallel, I saw that as the current increased, the resistance decreased. And then for the RC circuit, the time constant was 6.28 seconds, and I noticed that the magnitude of the current is very dependent on the time. And since we use a computer simulation for this experiment, a source of error would be human error when finding the times. And then lastly, we have the discussion questions. First, if the lab were done in real life, the results would be less accurate because we would have to take into consideration any real resistance. And then for the second question, from the simulation model, we predicted that the capacitor would charge immediately, but if we had done the experiment in real life with real life circuit components, then this would not occur because the resistance would be greater, which would cause the time to fully charge to be longer.